Hello and welcome to another episode of Pulse. I'm Sulagna Saha, technology editor of RCR Wireless News, and today we are talking to Matt Desch, CEO of Iridium. Matt, welcome. Thank you for joining us.
Thanks for having me.
Now, there's a lot of noise in the satellite industry of late. There's a lot of things happening in the direct to device and direct to cellular space, the rise of converged terrestrial, non terrestrial network infrastructure, new personalities like TerraWave, Leo, AST entering the market. And there is, of course, the growing awareness around PNT security. There's a lot to unpack. Matt, you have watched the industry take shape over several decades now. Iridium has been in the satellite service industry since very early. To start off, can you give us sort of a snapshot of how the industry has evolved in this time to where it is today?
It's several decades. I've been around quite a while, 20 years at Iridium, but really 40 years now in the wireless industry. I was
Okay.
involved when there were only, with cell phones, terrestrial cell phones, when there were only a million out there was when I really joined the industry. And I've kind of seen an arc really over that time where the expectations for mobility, have gone from a nice to have to absolutely imperative that we be connected all the time. And it's kind of hard for people to remember what it was like when we had bag phones and large things and flip phones, and we didn't have the internet in our pocket or on our screen or on our iPads, but it's becoming an imperative today. In the space industry or the satellite industry, when I joined 20 years ago after, being in terrestrial, it was a little sleepy, I would say. There were very defined interests. Devices were quite expensive, typically dishes, or even in the case of a personal mobility company like Iridium, a satellite phone or an IoT device were still pretty expensive and were purpose built proprietary devices. And there was a lot of failures in the industry because it was so expensive, so much capital to develop before you could even be in business. That's changed in the last 10 years. Lower cost launch, small satellites, and the big change really was when we all realized that phones were becoming powerful enough to actually make a direct connection to at least a low Earth orbiting satellite system, if not a geostationary one. And even in those cases, probably could do an okay job there as well. So that started happening about 5, 6 years ago. Clearly, Apple and the connection that they made for SOS and texting was sort of the first pass. We started developing a capability. Starlink and AST Space Mobile and others started to look at maybe reusing terrestrial spectrum and now more recently mobile satellite spectrum. So it's definitely a move right now. It's a big industry direction right now to connect people wherever they are. I mean, cell phones really still on the terrestrial basis only cover 10 to 14% of the Earth's surface and not in the air. But the fact that you could have a consumer device maybe connect in some way over a much larger part of the earth is exciting. And in fact, it's created a lot of investment, a lot of movement. Stock valuations are high as a result of that. People have looked to buy spectrum. I think one of the big questions still, and I've been asking it for a while, particularly given Iridium's history going back into the 90s and even cell phones before that, in my experience, is that, is there a business case? What will people pay for it? What will the capabilities really be? Will it work reliably, even indoors? Because that was a problem really with Iridium in the 90s when Iridium was first introduced and positioned as a cell phone alternative or cell phone replacement. And really, what will the customer experience and how much of the customer will use it? I think a lot will. I mean, I really do think that there's a lot of enthusiasm to use it, but it's also quite expensive, to deploy. If you're going to buy spectrum for $20 billion and build $10 billion worth of satellites and launch them every 5 years, which is really kind of the ongoing capital requirement of this, at least on a really big scale. It's not certainly the way Iridium is doing it, but that's still the question that hasn't been answered. And there hasn't been enough of it around to really answer that yet because not many people have experienced it and understand what that value proposition really is.
The direct to device space is also growing pretty hard every day, as you know, and there is a growing number of providers and carriers, including Iridium, is in that space. I'm curious at this speed of development, how long until D2C and D2D becomes mainstream?
I think mainstream is still a couple years away. I mean, everyone is announcing initial systems right now. You can use it. Certainly in some countries, Japan, China have basic capabilities in addition to, you could say, what you can get on your iPhone is mainstream today. I don't think many people have necessarily tried it or use it often. Certainly, given that it's free and its occasional capability, it hasn't moved the needle necessarily in terms of, device sales or things like that. So I don't think it's really achieved the potential that justifies valuations and investment and everything today. If that's going to happen, it's going to be, I think, at least 2 to 3 years away. We're not going to see truly global services. We'll be introducing, I think, the first truly global service that will operate everywhere later this year. It will still be not something necessarily implemented this year on cell phones at this point. It will be more of an IoT device so that existing 5G devices that accomplish the standard we're implementing, release 19 of the 3GPP standards here, can roam onto our network seamlessly anywhere in the world. And that's exciting, but that's still not, it's still going to be a nascent opportunity for most people, and most people won't really see that activity or changes in their life as a result of it. But, the idea that maybe you could do videos, or you could certainly get your email anywhere in the world kind of with attachments and lots of stuff on it, and be able to work pretty productively in a 2G, 3G kind of environment, as we all remember from, maybe 5, 6, 7 years ago. I think that's in, a year and a half, 2 years, 3 years. How prevalent that will be that everyone uses that, that's what we're all looking forward to understanding and finding out and seeing.
And direct NTN is coming, obviously. Where is Iridium with it? Is there an estimated timeline at this point for a commercial launch?
Yeah, I mean, we're right now live in kind of testing ourselves. We're in alpha and beta testing. We actually, our satellite, we're fortunate. We have a very flexible system that we launched. Our second generation system, which we called Iridium Next, was completed in 2019. It's a interconnected LEO system with satellites across the Earth, and it's programmable. So I'm fortunate that we could program our system to add a standards-based service. We were able to get that service through the standards bodies, and it's become a firm implementable standard really as of I think this month or last month, really, it's been published as a standard. The first chip manufacturers are now producing prototype chips or are developing their chips to support it. That will happen later this year in 2026. Our system, the ground infrastructure has been put in, it's in the softwares on all our satellites, and we're really tuning it now, actually demonstrating it to some early partners. Mobile network operators are starting to get a look at how it performs, and we're signing up mobile network operators around the world as roaming partners to allow it to roam onto them. So introduction later this year, when all that will come together, and I think we'll see that as another way. We're already the preeminent, by far the leader in satellite IoT. I mean, we have over 500 partners who have embedded us into thousands of applications in maritime, aviation, in government, in transportation, agriculture, energy, autonomy. Now, a lot of UAVs right now are put in our system, but those are all proprietary connections, very efficient, very cost effective, and 2 million devices or more out there. But now we'll start seeing more standardized devices and probably seeing us move into what I would call lower end applications. Maybe meter reading, for example, finally will be cost effective from a satellite perspective. Certainly livestock tracking, lots of applications which we really can't address today with proprietary systems, but would be a lot more cost effective since those are already applications been developed in the cellular industry and just need to roam when they're out of touch from a cell tower.
And we're seeing an increased urgency for positioning, navigation, and timing resiliency lately. And can you talk a little bit about why it has suddenly become so essential and why now?
GPS and other global navigation systems like Galileo, like GLONASS, like Baidu, those are medium Earth orbiting satellites that have very faint signals that have to be picked up by receivers kind of out of the ether. And they work extremely well. They're extremely accurate. And as a result of being free, the information, whether the navigation part or even just a timing source, has been integrated into everything digital, from cell towers to data centers to really everything we do right now is connected in some ways and needs a GNSS signal. And fortunately, conflicts have demonstrated that people realize that actually weapon systems, communication systems used on the battlefield, all those, they can be disrupted pretty easily by overpowering the GPS signal or by inserting, since they're not encrypted, spoofed signals to make the device think it's where it's not. And that is happening all over the Middle East right now, parts of Asia. It's even happening here in North America increasingly. And it's been demonstrated that it doesn't really take a lot of cost. It might be, even if it's illegal, you could take out a cell tower, you could disrupt, you can imagine at a sporting event or a major facility, if you could take down the communication systems, if you could disrupt the New York Stock Exchange, if you could disrupt a data center, you could really create a lot of havoc. So last 2 or 3 years, having flights, for example, the head of the European Union being spoofed, other things has created a acknowledgement really around the world that there has to be a fix for this. So, I think one of the reasons they're asking us is because we actually have the only really global solution to that, something we call Iridium satellite time and location. It was a capability. Actually, those who have been around our industry remembers paging, or Iridium, because it was developed in the 90s when paging was still there, was implemented with a very powerful paging signal as part of our capabilities because we had to reach pagers indoors and stuff. Now, we don't really support pagers anymore. I mean, that's not really a service that's widely in use, but that channel was something that we realized 10 to 15 years ago could be used to deliver timing correction signals, and we could encrypt that information. We could deliver it 1,000 times more powerfully than GPS. It could break through and be very difficult to jam or be spoofed, and even could just be a timing reference signal inside buildings where it's difficult to get a GPS timing source. So we developed that service. Actually, it was developed by Boeing Phantom Works and spun out into a private company called Satelles. And we had an investment. We bought back Satelles. And now this is one of our biggest growth areas really in the future. It's really being implemented across the world right now in maritime applications, whether in the Red Sea. We see drones right now to protect whether delivery or other kinds of autonomous vehicles. We're seeing it put into cell towers right now to protect critical infrastructure. It's going into the New York Stock Exchange, the NASDAQ. It's already been there for a while. It is really, we're seeing critical infrastructure of all type be protected via this kind of technology. And by the way, there are other ways of protecting GPS, but almost all of them are terrestrial. You need to have systems built around a city that use a different frequency and a different device. What we're offering is something that we're put into a chip, a tiny ASIC that really can be implemented in all kinds of things. And we think that's almost the platform that we can develop even other applications right now, things like identity management, some other things that we can build out a trusted location, which we can do. So I know we're a communication company, we're basically an IoT company for the most part, but the fact that we can offer this PNT capability, which is closely associated with IoT anyway. A lot of IoT applications need to protect the location of that information as well. it's been a really nice growth vector for us, and one we think we can build on in the future, and one that not others can do because they don't have L-band spectrum like we do, which is really the same spectrum that GPS uses. So you don't even need a different antenna. It doesn't need power. It's really, really a portable, highly efficient, cost-effective way to protect PNT systems.
Lastly, I want to get your view on what, in your opinion, truly takes to build that perfect connectivity across on a global scale, basically. If providers want to close the gaps in coverage, Iridium has pole-to-pole coverage with only 66 satellites and just a few backups. Several other providers have purposely kept their constellations small, whereas bigger players like Amazon and Starlink are all about more satellites. I'm curious what your thoughts are on that.
Yeah, it's funny. Iridium was the OG, as we say, of low Earth orbit. They thought we were crazy back in the 90s when the system was implemented. Just launching 66 satellites, actually, almost 100 were totally launched back then, and we launched 81. That was considered to be massive numbers of satellites, and it really scared people a lot back then. Now, when I entered the industry in 2006, I think there were about 4,000 active satellites over the previous 60 years. That's a total number of active satellites, of which we had, about 80. Now there's 10, 12,000, and we're heading towards hundreds of thousands potentially. And obviously, there's people are concerned about things running into each other. We're worried about that as well. But frankly, we're all doing a good job of keeping ourselves apart from each other. But what has really kind of changed a little bit more, more doesn't necessarily mean better. It's really the kind of services you offer. For example, we don't really compete directly today with Starlink or Amazon Leo or OneWeb, or most of those really offer services using completely different frequencies and a totally different kind of service, a broadband service versus a personal communication services. There might be more competition maybe out in the future with direct-to-device, but we already are offering something quite unique because of our spectrum, because of our history, because of the kind of services we offer like PNT. So just having more satellites doesn't mean you offer the same thing. It's also what frequency you use, how your system is architected, the kind of services that you propose to do and specialize in. So there's not an optimal capability. I mentioned earlier, there's a lot of question about profitability long term. I will say Iridium is quite profitable today. We're successful. We're continue to grow, but it took us 30 years to get here too. Satellite systems are quite expensive. They're capital intensive, especially communication networks have to be completely built out. You can't have a LEO service with just a couple satellites because you can't provide continuous service until you get a full constellation and perhaps even things like inter-satellite links. So they're very expensive to develop. And then if there are so many different competing systems, then you wonder, can you generate the revenues necessary to continue to provide the capital necessary to keep those systems in operation? We were fortunate to develop, well, initially satellites were thought to last 7 to 8 to 9 years. We were fortunate our first generation lasted 20 years. We think this generation could last 20 years again, but almost everybody are launching these mega constellations with 5-year to 7-year satellites. So that means they have to replenish them constantly. If you don't have your own rocket, which some do, but most don't, that's a real challenging capital expense. And so you have to generate massive amounts of revenue to be successful in the long run. So that's the question today. I mean, that's the trade-off. If you're talking about, if you want to, become an entrepreneur and build your own mega constellation, I hope you think about that. You might want to start building your own reusable rocket and then go forward and build a system. Just an idea. But even so, even if you don't do that, you really, really got to go big, in some ways and become a major supplier and have the financial wherewithal to last the probably long period of time it'll take before you become truly cash flow positive and able to generate a sustaining system, that will support itself well into the future. So hope that answered the question.
This is very interesting. Thank you so much, Matt, for doing this.
Glad to, Sulagna. Thank you.